My goal today to talk about chapter 10 a little bit. It's a lot of geometry. Uh, you're going to have to know different things. On the screen you'll see the beginning of something. You'll see a triangle here, and you have to be able to understand what the parts are to the triangle. So I'm going to walk you through what the triangle parts are so that you can understand how to set a problem up. So if we have a right triangle here, and we know the altitude is the height, so that's our A side of the triangle. The base of the triangle is our B side, and the hypotenuse, which is the longest side, is C. Now, how do you remember that? Well, I always like to try and show students that if I finished this out, I'd have a square, and I cut the square in half. So it's A is a different length. A is going to be A over here also. B would be flipped up here. And C is that cut I make through the middle to make that into a triangle. So that's one way to remember it. There are other ways too. But I just wanted to show you what this geometric shape really looks like. It's really a square that's been cut in half. And this distance from this corner to this corner will always be the longest distance. So now all we have to do, now that we know what the parts are, is just fill in what we know. A is 24 to the second power, so we have to square that. And then added to B, which is 32 squared, equals the C squared. So when we square those numbers, we get 576 added to 1024, and that all equals the C squared. This is called the Pythagorean theorem, and a man named Pythagoras discovered how to cut a triangle, a square in half, so that you would have two right triangles. So this becomes 1600 equals C squared. Sometimes just learning history about math can be interesting. I know that some of you wouldn't agree. Now you get to this point, you say, well, how do I get this to be just C? Well, if I take the square root of this side and the square root of this side, what do I get? Well, underneath on this side, I have C times C. This is a marriage of two. They want to know what is the base of C when I use this. In this case, it's C. Okay? A marriage comes out as a single, so we have C. The next thing is, on your calculator, you have to push second function, square root symbol, and then put 1600 in it, and you'll get 40. And if you want to check yourself, 40 times 40 is 1600. So you can factor these also if you need to. So that's our first little example that we're going to look at. Next, we're going to go to a circle. So we've in this circle, they're just going to give you the diameter of a circle, and they want you to find the radius. So let's look at the diameter of the circle. The diameter in this case equals 30 centimeters. That's really all the information you need about the circle. They're saying I have a circle, and if I cut it in half, that means diameter. This distance here is my 30 centimeters. Okay, so that's diameter. Now, the one thing that you have to know about diameter is if I split diameter in half, I'll get the radius of the circle. So what we really need to do is if we just say we start here and go here, what is the distance? It's half of 30, so this becomes 15 centimeters. So that's something that you have to deduce on your own. So the area of a circle, and I always like to put little symbols in, so the area of a circle is equal to pi radius squared. So that's why we have to divide this diameter in half so that we have the radius, and then all we have to do is fill in the information, which in this case we're just going to use the approximation for pi, which is 3.14 times the radius, which is 15 squared, and then we'll end up with if we multiply this together, we get 706.5 centimeters squared. So that's what you'll do for that type of a problem, is you have to, the most important thing here is have this in your notes. You have to understand what you're looking for. This is the area of a circle equals the radius squared times pi. And that's one of the examples for the geometry. The next example is to find the circumference of the circle. So how do we find circumference? We have to know what this formula for circumference is. Let's see, we want this color. The circumference of a circle. Now, what's that mean? If we take a circle and we start in one spot and we travel around the circle, what is the distance around it? It's kind of like perimeter, except for a circle, it has to be circumference because there's no edges. It's just one continuous line, unlike on other geometric shapes like the perimeter of a rectangle, for instance. Totally different. We have two sides alike and two sides alike, right? In this case, we don't have sides, we just have the distance. So the circumference of the circle is twice pi times the radius. So in this case, they're telling us that the circumference, we have to have a little information, right? The radius of this circle, the radius equals 25 centimeters. So we have the information we need, we just have to plug it in. Twice pi, 3.14 here, right? That's what you're going to put, times the radius of 25 this time. We don't have to cut it because they gave us the radius in its form. So then if we do 6.28, sorry, brain's going too fast, can't keep up with myself. That's twice pi times the 25. We should end up with the circumference of this circle equaling 157 centimeters. It's the distance around that circle. So that's another one that we'll have to understand. Circumference of a circle, area of a circle. So another important fact that you need to take with you is understanding how this formula works. So we're teaching you formulas now for geometry because that's what it is. Now, the next thing, we introduced it in the first because we used the Pythagorean theorem. We looked at square root value, but I want to go into it a little bit more because you're going to get it more. So let's do the square root of 64 over 100. Make an easy one. Now, there's a couple ways you could do this. I'll show you both ways, so I'm going to rewrite this so that you can see what I'm doing. They're all underneath here. The first way you could do it is say the square root of 64 over the square root of 100. I could distribute the square root symbol because it's part of this whole thing. It says the whole fraction has it. Then I can factor the top one is 8 times 8. And I can factor the denominator, which is 10 times 10. Now when we work with square roots, we're always looking for the base. So for example, if I had 8 to the second power, what is the base of that number? It's the 8. So that's what we were talking about. If we have a marriage like this, the 8 comes out as a whole number. So this 10 would come out as a whole number because this is really 10 to the second power. The square root symbol actually is saying, this tells us to square it. This tells us to find out what the base is. So we're looking for the base. A marriage of 2 comes out as a single. So it's kind of like these two people get married and they become one. And then in order to finish this, we have to reduce it. Half of 8 is 4, and half of 10 is 5. So this is the same thing, it's just that we leave the symbol over the whole thing. We have 8 over 8 times 8 over the 10 times the 10, which equals the 8 over the 10, which reduced to our 4/5. So that's the explanation for that. This symbol means what is the base represented in here? In other words, which two numbers squared together created the number? Okay, it's kind of a backwards thinking from what you're used to. 10 to the second power is 100. Well, what made that? The tens. And their marriage of 1. The next thing we look at is changing numbers into the same equivalent number. And for the metric system, we're going to look at some conversions. So here you go. We're going to look at something that I like to teach students as King Henry drinks dark chocolate milk. That's kilometers, hectometers, decimeters, decimal, centimeter, milliliter, millimeter, milligram, whatever. I like to teach students that this is like a balance beam. And this is where the kilo is, which means 1,000, and this is where the milli is, which means 1,000. We have all the points in between. We have the hecti, the deci. This is the unit. It's kind of like number 1. So this is the units. So I'm going to say this is liters right now. Sorry, can't read my writing, neither can I. So let's start. And then we have the decimal, which is deci, deci, centi, milli, okay? So here you go. They're going to ask you to convert 18 milliliters. And let's go first to liters. So how many liters would it be? So here it is. It stands right here as 18. And it wants to go to the units right here to liters. So how many shifts is it? It's taking up 1, 2 positions right now, so it needs something here. So in order to get to here, I have to have a 0 in front of it. And it's still not in the whole unit yet. So this becomes 0.018. Now as I go this direction, this number, if it's in this position, is going to get smaller. So the next thing they want me to do is make it into kiloliters, okay? I say kilo so that you understand it's K-I-L-O, the Greek for 1,000. So then I say, well, how many spaces is that? I have 1, 2, 3. I should have put the 1 here for you to see it. 4, 5, 6. Now move my decimal. So I have point, and there's 1, 2, 3, 4 zeros. 1, 2, 3, 4, 5, 6. There are 6 positions across here. In order to get all the way to here, I have to have all 6 represented. So, whoops, that's 8. I don't know where I got the 6 from. So here they are. 1, 2, 3, 4, 5, 6 positions. So here it is, 1, 2, 3, 4, 5, 6 to get the kilo. So those are the types of conversions you'll do. If you can use King Henry to start chocolate milk, put your number up here like this, you'll be great and fine, and you'll have it every time. And you'll understand